The universe is 13.8 billion years old. It contains 2 trillion galaxies. Each galaxy has hundreds of billions of stars, and we now know most of those stars have planets. The math is staggering. There should be billions of Earth-like planets in our galaxy alone, planets where life could evolve, where civilizations could develop technology, where intelligent beings could build radio telescopes and spacecraft. So here's the question that keeps scientists awake at night. If the universe is so vast and the probability of alien life is so high, where is everybody? Why haven't we seen any evidence of alien civilizations? No signals, no megastructures, no signs of anyone out there. This is the Fermi Paradox, and it's one of the most disturbing questions in all of science, because every possible answer is terrifying in its own way. Welcome back to Beyond Our World, where science meets mystery. I'm your host, and today we're diving into what might be the most important question humanity has ever asked: the Fermi Paradox. Named after physicist Enrico Fermi, who asked this question over lunch in 1950. If aliens are probable, where are they? This isn't just a casual question. It's a paradox that strikes at the heart of our existence. Are we alone? Are we early? Are we late? Or is there something out there we haven't discovered yet? If you're new here, this channel explores the greatest mysteries of space and the universe. We examine real science, present multiple theories, and let you decide what to believe. Make sure to subscribe and hit that notification bell because we post new space mysteries every Monday, Wednesday, and Friday. Now, before we explore the possible answers, we need to understand why this paradox exists in the first place. Let's look at the numbers. And trust me, they're mind-blowing. Our Milky Way galaxy contains between 100 and 400 billion stars. That's a lot. But we're just one galaxy. The observable universe contains an estimated 2 trillion galaxies. Do the math. We're looking at something like 200 billion trillion stars. That's a 2 followed by 23 zeros. Now, thanks to the Kepler Space Telescope and other missions, we know that planets are incredibly common. NASA estimates there are more planets than stars. At least one planet per star on average. Many stars have multiple planets. So we're talking about hundreds of billions of planets just in our galaxy. But not all planets can support life. We need to narrow it down. Planets in the habitable zone. Not too hot, not too cold. Where liquid water can exist. Scientists estimate that about 20 to 50% of stars have planets in the habitable zone. Let's be conservative and say 20%. That's still 20 to 80 billion potentially habitable planets in our galaxy alone. 20 billion Earth-like worlds. In just our galaxy. And remember, there are 2 trillion galaxies, the numbers become almost meaningless, they're so large. Even if only a tiny fraction of those habitable planets actually develop life, we should still be looking at millions or billions of civilizations in our galaxy. So where are they? This is where the Drake equation comes in. In 1961, astronomer Frank Drake created an equation to estimate the number of active, communicative alien civilizations in our galaxy. The equation considers factors like the rate of star formation, the fraction of stars with planets, the number of habitable planets per star system, the fraction where life actually develops, the fraction where intelligent life evolves, the fraction that develop technology capable of communication, and how long such civilizations last. Plug in even conservative numbers, and you get anywhere from dozens to thousands of detectable civilizations in our galaxy right now. And if civilizations last a long time, that number could be much higher. But here's the problem. We've been listening for over 60 years. The SETI Institute has been scanning the skies for radio signals since the 1960s. We've examined millions of star systems. We've looked for artificial signals. We've searched for signs of megastructures like Dyson spheres. We've found nothing. Silence. Complete and total silence. This is the Great Silence. And it demands an explanation. Enrico Fermi understood this paradox immediately. During a casual lunch conversation at Los Alamos in 1950, he suddenly asked, "Where is everybody?" His colleagues knew exactly what he meant. If intelligent life is common, and if even a small fraction develops space travel, the galaxy should be teeming with evidence of alien civilizations. Even traveling slower than light, a civilization could colonize the entire galaxy in just a few million years. That sounds like a long time, but the Milky Way is over 13 billion years old. There's been plenty of time. In fact, any civilization that arose even a few million years before us should be everywhere by now, but they're not. Or at least, we see no evidence of them. So what's going on? Scientists have proposed dozens of explanations. And honestly, each one is disturbing in its own way. Let's explore the major possibilities. And I warn you, some of these will make you uncomfortable. The first explanation is the simplest. We're alone. We are the only intelligent life in the observable universe. Life is so incredibly rare that it's only happened once. Us. This is called the rare Earth hypothesis. Proponents argue that Earth is special. We have a large moon that stabilizes our axis. We're in the galactic habitable zone, not too close to the chaotic galactic center, not too far in the stellar desert. We have Jupiter as a shield, deflecting asteroids. We have plate tectonics that regulate our atmosphere. We have a magnetic field protecting us from radiation. The list goes on. Maybe the conditions for life are so specific, so unlikely, that Earth really is 1 in a trillion. Maybe we're the first. The problem with this explanation is that it requires life to be absurdly rare. And everything we're learning about astrobiology suggests otherwise. We've found organic molecules in space. We've found water everywhere we look. Life arose on Earth almost as soon as conditions allowed it. Life seems to want to happen. But maybe intelligence is the rare part. Maybe simple life is common, but the jump to intelligence is incredibly unlikely. This brings us to the second explanation, the Great Filter. This is perhaps the most terrifying answer to the Fermi Paradox. The idea is that somewhere between primitive life and galaxy-spanning civilizations there's a barrier, a filter that almost no one passes through. And we don't know what it is. Maybe it's behind us. Maybe the jump from non-life to life is incredibly hard. Or from single-celled to multicellular. Or from animal life to intelligent life. If the filter is behind us, that's good news. It means we've passed the hard part. But maybe the filter is ahead of us. Maybe something prevents civilizations from lasting long after they develop advanced technology. Nuclear war, climate catastrophe, artificial intelligence gone wrong, engineered pandemics, resource depletion. Maybe every civilization reaches a point where they destroy themselves. And maybe we're approaching that point right now. The terrifying thing about the Great Filter is that the silence of the universe could be a warning. It could be telling us that intelligence is self-terminating, that we're doomed to the same fate as countless civilizations before us. Here's another possibility, and it's equally unsettling. Maybe they're already here. Maybe Earth has been visited, or is being visited, and we don't realize it. This is the zoo hypothesis. The idea that advanced civilizations know about us but are deliberately avoiding contact. Maybe we're in a cosmic zoo or nature preserve. Maybe there's a galactic policy of non-interference with primitive species, like Star Trek's Prime Directive. They're watching us but not interacting. Some UFO researchers point to UAP encounters as evidence of this, but the scientific community remains skeptical. If aliens are visiting Earth, why be so secretive? Why not make contact? Unless, of course, they have reasons we can't comprehend. Maybe they're so advanced that we're like ants to them. You don't introduce yourself to an ant colony. You observe it, or ignore it. This explanation requires that all advanced civilizations agree to hide from us. That seems unlikely, unless there's a galactic government enforcing such rules. Then there's the possibility that we're early. Maybe we're among the first intelligent civilizations in the universe. The universe is 13.8 billion years old. But the first generation of stars didn't have the heavy elements needed for planets and life. Those elements had to be created in supernovas. It took several billion years for the universe to become chemistry rich enough for Earth-like planets. Maybe the window for life-bearing planets only opened a few billion years ago. Maybe we're in the first wave of intelligence in the cosmos. If that's true, the universe might be teeming with life in another billion years. But right now, we're alone simply because we're early to the party. This is actually one of the more optimistic answers. It means the silence isn't because intelligence destroys itself, it's just because we're pioneers. But it also means an enormous responsibility. What we do now could determine the future of intelligence in the universe. Here's a darker possibility. Maybe advanced civilizations exist, but they're all hiding. This is called the dark forest hypothesis, popularized by science fiction author Liu Cixin. The idea is that the universe is like a dark forest. Every civilization is a hunter with a gun moving through the trees. When you detect another hunter, you face a terrible choice. Do you reveal yourself? Do you try to communicate? Or do you shoot first? Because if they're more advanced than you, they could destroy you. And if they're less advanced, they might become a threat later. The safest strategy is to stay silent, to hide, to never reveal your location. And if you detect someone else, you eliminate them before they can threaten you. In this model, the reason we haven't heard from anyone is that broadcasting your existence is suicide. Any civilization that shouts into the cosmos gets destroyed by someone more powerful. The survivors are the ones who stay quiet. If this is true, then our efforts to send messages into space, like the Arecibo message in 1974, could be catastrophically stupid. We might have just painted a target on Earth. We might have doomed our species by announcing our presence. Maybe the problem is technology. Maybe we're looking for the wrong signals. We're scanning for radio waves because that's the technology we use. But what if advanced civilizations have moved beyond radio? What if they use quantum communication, or technologies we haven't even imagined? We could be like someone in the 1800s trying to detect modern civilization by looking for smoke signals. We're using primitive tools to search for advanced beings. They could be communicating all around us, and we wouldn't even recognize it as communication. Or maybe they've transcended physical existence entirely. Maybe sufficiently advanced civilizations upload themselves into virtual realities. Why bother exploring the physical universe when you can create infinite perfect worlds in a computer? This is the transcension hypothesis. If this is true, we wouldn't detect them, because they're not out there anymore. They're in there, in digital paradises of their own creation. Here's another angle. Maybe space travel is just too hard. We imagine that any advanced civilization would eventually spread to the stars, but maybe that's wrong. Maybe interstellar travel is so difficult, so expensive, so dangerous that no one bothers. Even at 1/10 the speed of light, which is wildly optimistic, it would take 43 years to reach the nearest star system. Generations would live and die on the journey. For what? To reach a planet that might not even be habitable? Maybe every civilization does the math and decides it's not worth it. Maybe they stay home. This would explain why we haven't been visited. But it doesn't explain the lack of signals. Even if no one travels, they could still communicate. Unless they've decided not to. Unless every civilization concludes that shouting into the void is pointless or dangerous. Let's talk about something even stranger. The simulation hypothesis. What if our entire universe is a computer simulation? What if we're living in a programmed reality created by some advanced civilization? In that case, we might not find aliens because the simulation isn't programmed to include them. We're alone because whoever is running the simulation decided we should be alone. Maybe they're studying how a civilization develops in isolation. Or maybe the simulation is resource limited. Maybe rendering two civilizations is too computationally expensive, so they only simulate one, us. This sounds like science fiction, but serious philosophers and physicists have considered it. If it's possible to create realistic simulations, and if civilizations routinely do so, then statistically we're more likely to be in a simulation than in base reality. Because there would be countless simulations, but only one base reality. If this is true, the Fermi Paradox is solved. We're alone because the programmer made us alone. Here's a possibility that gets less attention but is quite plausible. Maybe intelligence isn't useful. Maybe being intelligent is actually an evolutionary disadvantage in the long run. Think about it. Humans have been around for 300,000 years. For most of that time, we lived like other animals. Technology is only about 10,000 years old. Industrial technology is only 250 years old. We've been capable of destroying ourselves with nuclear weapons for less than 80 years. Maybe intelligence leads rapidly to self-destruction. Maybe creatures that stay simple, that don't develop technology, are the ones that survive. Maybe the universe is full of life, but almost none of it is intelligent. And the few species that become intelligent don't last long. Dinosaurs ruled Earth for 165 million years. Humans might not make it to 1 million. Maybe intelligence is a flash in the pan, bright and brief, and then gone. Now let's consider the berserker hypothesis. Maybe there are or were many civilizations, but there's also a hostile force that destroys them. Some kind of self-replicating probe, or AI, that travels the galaxy eliminating any intelligence it finds. Like a cosmic immune system. This could be an ancient weapon that's still operating, or a civilization that actively hunts down competitors. If such a thing exists, the silence makes sense. Everyone is either dead or hiding. And we're next. Unless we stay quiet. This is another reason some scientists oppose METI, messaging to extraterrestrial intelligence. We could be attracting the attention of something dangerous. Here's a more mundane explanation. Maybe civilizations don't last long. Not because of catastrophe, but because of transformation. Maybe every advanced civilization reaches a point where they change into something we wouldn't recognize as a civilization. Maybe they merge with their technology. Maybe they engineer themselves into something post-human. Maybe they discover something about reality that changes everything. Maybe they find a way to escape into higher dimensions or parallel universes. Maybe the endgame of intelligence is to leave this universe entirely. In that case, we wouldn't find them because they're not here anymore. They've moved on to something beyond our comprehension. There's also the possibility that life exists but is too different from us to recognize. Maybe we're so focused on carbon-based, water-dependent life that we're missing entirely different forms of biology. Maybe there are silicon-based organisms living in the clouds of Venus. Maybe plasma-based entities exist in the coronas of stars. Maybe there are slow-thinking, large-scale organisms living in interstellar gas clouds. Their thoughts taking millions of years. We wouldn't recognize them as life because they're so alien to our experience. This is the idea that life is far more diverse than we imagine, and we're looking for the wrong thing. So what do scientists actually think? The truth is, there's no consensus. The Fermi Paradox remains one of the great unsolved mysteries, but recent developments have made it more urgent. In the last 30 years, we've discovered thousands of exoplanets. We know Earth-like worlds are common. We found organic molecules in space, we found potential biosignatures on exoplanets. Life no longer seems implausible, it seems probable. Which makes the silence even more disturbing. In 2015, astronomer Seth Shostak estimated that if civilizations are common, SETI should detect a signal within the next 20 years. We're halfway through that prediction. Still nothing. Astronomer Jill Tarter, who led SETI for decades, compared our search to scooping one glass of water from the ocean and concluding, there are no fish. We've barely begun to look. The universe is vast. Maybe we just haven't looked in the right place or the right way yet. But the clock is ticking for us. We're facing existential risks. Climate change, nuclear weapons, engineered pandemics, artificial intelligence. If the Great Filter is ahead of us, we need to identify it and survive it. The Fermi Paradox isn't just an abstract puzzle. It's a potential warning. The fate of every other civilization could be our fate too, unless we figure out what went wrong for them and avoid it. Some scientists argue we should stop broadcasting our presence until we understand the risks better. Others say we should increase our efforts to contact alien civilizations, because if they exist and we can learn from them, that knowledge could save us. The debate continues. Looking ahead, new technologies might help us solve the paradox. The James Webb Space Telescope can analyze the atmospheres of distant planets. If we find technosignatures, evidence of industrial pollution or artificial chemicals, we'd know intelligent life exists or existed. Future radio telescopes will be more sensitive. The Square Kilometer Array, currently under construction, will be 50 times more powerful than any existing radio telescope. If there are signals out there, we're getting better at detecting them. And missions to Europa, Enceladus, and Mars might find microbial life in our own solar system. If we find life independently arose multiple times just in our neighborhood, the Great Filter is probably behind us. But if we search everywhere and find nothing, that's bad news. It might mean life is absurdly rare, or that something prevents it from lasting. So where does this leave us? The Fermi Paradox has no easy answer. Each solution is profound and disturbing. Maybe we're alone, the only intelligence in a vast dead universe. Maybe we're early, pioneers in a cosmos that will eventually bloom with life. Maybe we're in danger, about to hit a filter that destroys civilizations. Maybe they're out there but hiding, or too advanced for us to detect, or living in simulations, or transformed into something we can't comprehend. Or maybe, just maybe, they're on their way. And we'll find out soon, one way or another. So what do you think? Where are the aliens? Are we alone? Are we in danger? Or are we just not looking hard enough? Drop your theories in the comments. I love reading your thoughts on these big questions. If you enjoyed this deep dive into one of science's greatest mysteries, hit that like button. And make sure you're subscribed with notifications on because we post new space mysteries every Monday, Wednesday, and Friday. Next time, we're exploring Europa, Jupiter's moon with a global ocean beneath its ice. Could alien life be swimming in those dark waters right now? We'll examine all the evidence. Until then, keep looking up. And hope that when we finally hear something from the stars, it's a friendly message.